Okay, in this team challenge, which is a little more tricky than the last one, this is number 8, we have several parts we have to do. The first part is to calculate a delta G naught at 2 different temperatures given 2 different KEQs. So we're going to use the equation delta G naught equals negative RT ln KEQ. And we have the case that temperature number 1 is 37 degrees Celsius, which is equal to 310 Kelvin. If we put that in, we have the delta G naught equal to negative 8.3145 joules per Kelvin mole times 310 Kelvin times the ln of KEQ. And in this case, the KEQ is given as 1.796. This gives us a delta G naught of negative 1.509 kilojoules per mole. Or you could express that as negative 1,509 joules per mole. We do the same thing at 45 degrees. And that is equal to 45 plus 273 is equal to 318, I guess? 318 Kelvin. So this is going to be equal to the same bit of math, except we're going to put the right temperature in here, and we're going to put the right KEQ. In this case, the KEQ was 15.684, and that will give us a delta G naught of negative 7.278 kilojoules per mole. This is pretty straightforward. Plug and chug, plug it into the equation, and get the right answer. The next part is a little bit trickier. It says that delta H naught and delta S naught are independent of temperature, and what that means is that at 37 and 45, those values of delta H naught and delta S naught, they're the same at the 2 temperatures. Okay? So it asks you to determine those 2 values given the information from the previous question. Well, I have a temperature and a delta G naught for each of those things. So I can do this. I can say delta G naught equals delta H naught minus T delta S naught. And I have 2 different delta G's and 2 different temperatures. So I'm going to put them in. I have negative 1509, I'm just going to do this in joules per mole now, is equal to delta H naught minus 310 Kelvin times delta S naught. And I have the negative 7.278 joules per mole is equal to delta H naught minus the other temperature, 318 Kelvin, times delta S naught. Now what we have is 2 equations and 2 unknowns. The way my brain deals with this is to solve for delta H naught. So I would rearrange this, and I'll actually write out the steps. I'd say delta H naught here is equal to negative 1509 joules per mole plus, because I'm putting that stuff on the other side, 310 Kelvin times delta S naught. And here delta H naught is equal to negative 7.278 joules per mole plus 318 Kelvin times delta S naught. But the great thing, of course, with this being 2 equations and 2 unknowns is that this is independent of temperature, so I can set one equal to the other and say negative 1509 joules per mole plus 310 Kelvin times delta S naught is equal to the other version of this, 7.278 joules per mole plus 318 Kelvin times delta S naught. I'm not going to do the math for you, but all you have to do is isolate the delta S naught and the numbers and divide through, and what that is going to give you is delta S naught equal to 721 joules per Kelvin. That's a big K, mole. And by substituting back into this equation, you can solve for delta H naught, which is 222 kilojoules per mole. Note that they're in different units, right? This one has a kilo in front of it. The final part of the question is to figure out at what temperature this is at equilibrium. And from this equation here, we can solve for the temperature at equilibrium because delta G will be equal to 0. So the temperature at equilibrium is going to be equal to delta H naught over delta S naught. And that would be equal to 222,000 joules per mole divided by 721 joules per Kelvin mole. We will get an answer in Kelvin, which is 307.9 Kelvin, which is equal to 34.9 degrees Celsius. Now I'm not going to tell you the answer to the final part, that's the second part C, that you can hand in on Tuesday if you'd like the bonus marks on your team challenge.